Hello YouTube, welcome to my vid tutorial. Today I'm going to teach you all you need to know about VOR. Please stay with me during this video. The stuff you're about to learn may seem difficult, but actually it is quite simple and easy to learn. Okay, so what is VOR, you might ask? VOR stands for Very High Frequency Omnidirectional Range. Or do we just use VOR for short, since that uses up a lot of radio space? VOR nowadays is obsolete and mostly used just by civil aviation and private pilots to navigate. And that's exactly what we're going to use it for today. Okay, so I have a map of the United States right here. Kinda neat, huh? What we can see is if we had VOR vision, we would see all kinds of lines and patterns. So, let's imagine this map with thousands and thousands of red polka dots. Alright. Now I know most of you guys don't have colorful imaginations, so I drew this map for you. This will better dictate how VORs work. As you can see, the red dots are the individual VOR stations. The lines in between them are called vectors. These vectors are virtual highways in the sky that you can fly across. Literally, you can fly across them. Usually on these vectors, these highways in the sky, there is very little traffic, toll booths, police cars, ticket cameras, and any other little nuisances that you'd find on the road. Moving on now, we're going to zoom down even further down to the individual station itself. The red lines you see are the North and the South Pole lines. These are the stations positioned to the North and South Pole. Magnetic North and South Pole. We don't use geographical North and South Pole. The green lines you see, however, are the actual vectors, the lines that you actually fly across, past the station over, and onto your destination. Every VOR station can be further subdivided and divided into 360 parts, called radials. Now, starting with 0, which is magnetic north, going all the way around to 359 degrees. We do not use 360 degrees for north. Now, some of these radials are very, very special because they directly connect two VORs that are close to each other. This is what we call a vector. Now, I know your head might be spinning and spinning and spinning right now from all the information, but right now you might be asking, how will this help me? How do I use this? Okay, let's flash back to those VOR 1 and those VOR 2 gauges. Now, you see those numbers on the circumference of the gauge? Those numbers correspond with that compass rose that I just shown you. Now, when you want to select a heading to fly, you turn the knob, that OBS knob that you see in the bottom left of the gauge, you turn it until the heading number is matched up with the arrow on the top of the gauge. Once that is done, and as long as you're tuned in with the VOR and you're within range, that needle in the center will start to fluctuate. Now, the needle shows your position relative to the radio. If you're left of the radio, the needle will swing right. If you're right of the radio, the needle will swing left. The needle tells you where to correct. So basically, all you have to do is fly towards the needle. But remember, the closer you get to a station, the more sensitive the needle gets. Okay, we're moving on now. Don't worry about that horizontal bar in the left gauge. We'll use that later. That's for something completely different. Alright, so you're all situated now. You're flying, you're on your radial, you're heading towards the station, and you're wondering, wait a minute, when I fly over the station, what happens? What will happen to the needle? Well, the only thing that will happen to the needle is that it will get more sensitive. Other than that, you'll continue on your course. When you want to select a radial to fly, you have to first know where you are starting from. Let's say you are starting perfectly exactly east of the station. So if you were standing at the station and you looked at the airplane from where it was, you would see that it would be exactly on the radio 090. And let's just say you were flying any direction. But you wanted to follow the radio and you wanted to go exactly west, following a radial outbound west. So you would pick the radio 270, since it's the opposite of where you currently are. Okay, to better explain this, let's use a real-world example. Let's say you're in Chicago, and if you were at the station and you looked at Chicago, you'd see Chicago is exactly on the heading 040, which is just up and to the right, as you can see down here, 040. Now, you're taking off, and you want the reciprocal of 040. So you go down and look for the reciprocal. 220 is the reciprocal in this case. So in your nav radio, you would plug in 220. Now, the needle would fluctuate, and once you get on your radio of 220, the needle will be straight vertical, meaning that you're right on with your vertical and you can continue flying. Once you arrive at the station, we want to make a right turn. We want to make a right turn to 250. So we go and we turn our knob and we set the number to 250. The needle then turns because it knows that we're not on the right course for 250. We correct this, we get back on course, and then we're on the heading 250. Now we can see how we would travel over great distances using this. We would bounce from station to station, radial to radial. Well, in this case these are vectors because they connect to VORs, vector to vector, and we could actually get places and not get lost. Even if it was completely cloudy or foggy or stormy or whatever, we would still have that navigation, since the radio waves can travel through pretty much anything that, isn't rock or isn't metal or anything, travel right through the air. And this allows you to travel at night or when you can't see, when visibility's poor, just explain that. And don't mind the map, I did all this in about 5 seconds. Although VOR is not used in commercial aviation anymore, it is being replaced by GPS. Since GPS is much more accurate, it can transmit data, and it can calculate all kinds of things, such as fuel, departure time, arrival time, all that good stuff. And it's pretty much just outdated, since it's, not preferred, and it can be tedious, and, it's harder to learn. A GPS is easy. You just push buttons, and, it pretty much does all the work, since it's a computer. There's a lot of math, number crunching, data, you have to time, but you will not get into that when you're flying a simulator. You'll pretty much just be using it, just bouncing station from station, but that's why they don't use it anymore, since it's pretty much obsolete. Short and sweet. Alright everyone, now we're going to move on to something fun, and I guarantee you're going to use this. Now, if you watched my previous video, you may have seen this gauge working. This is the VOR 1 gauge. This is exactly the same as the other gauge, except it has a little feature that I love, and it's called the glide slope indicator. The other gauge does not have it. It is that horizontal bar that you see. Now, the only difference between this and the other gauges is that this one is powered up, and as you can see, the lines are just out of center. Now, as you can see, we're a bit high and to the left, but this is just a picture. So, if this were real, you would be too high and to the left. Now, the horizontal bar gives you vertical guidance. It tells you if you're too high or too low. Right now, we're a little bit high. So if this was a real landing, we would lower the nose a bit. We'd push forward on the stick. As you can see, we're a little bit to the left because the needle is deflected to the right. So we'd correct right a bit. We'd give a little bit of right aileron. So, with this in mind, we can use this to have what is called a precision landing, which means that you can get right on there. That little circle you see is where your airplane is, and that X is where your airplane should be. As if this was a algebraic problem, the solution of these two lines is where your airplane should be. So the crosshair, that point where the two lines intersect, the solution is where your airplane should be. And your goal is to get that white circle onto that spot, that point in that matrix of space. Now, one of the best things of this gauge and the other VOR gauge I forgot to mention earlier is that you can use the autopilot with them. So that way you can stay on your VOR radio by just using the autopilot. It means that it'll keep your horizontal navigation, it'll keep you right on the radio, and you won't have to, stress out about keeping your airplane straight and correcting. It means you can worry about other more important things, such as fuel or navigation, or the autopilot makes life easier for you if you make it easy for the autopilot. Okay, so we learned how to use a VOR, we've learned about radios, we've learned about ILS landings, we've learned about somewhat how to use the autopilot, which will be in my next video, and we pretty much learned about these two gauges. Thanks for watching.